All right, so 4.8a. This is actually, it should go pretty quick. It'll probably take us about 25 minutes, I would guess, somewhere in there. And you'll have some time. I'll check in. I think it's just 4.6 and 4.7 that I have to check in, and then 4.5b. Last time I said I would check in for full credit as well. So if you have that, you can show me that.
Wait, we got full credit for all that stuff last couple weeks.
No. And then but we'll have time to work on the homework as well. All right. So starting off, solving our triangle. This is actually, I think it was 4.2 or 4.3 we learned this. But what does it mean to solve a triangle?
Find the sides and angles.
Yeah, find all sides and angles, right? So in this one, we already know angle C is 90. And we're told A is 62.7 degrees. And we're told that side A is 8.4. So, one thing I want you to notice, and we'll see this more and more in the future, a lot of times when we're doing trig, the angles will be represented by capital letters on a triangle, capital letters or Greek letters, right? So depending on the book, sometimes they use A, sometimes they use alpha. Sometimes they use capital B, sometimes they use beta, and then gamma. So, but our book uses capital letters to denote angles, lowercase letters to denote sides of triangles. And then they always go together where if angle A is here, it opens up to side A. If angle B is here, it opens up. It's the opposite side is side B. Does that make sense? So originally, you might even notice on your note sheet, they're not labeled, right? It doesn't matter where you put A and B, really. You could have A up here and B down here. But just make sure you're consistent. If this was angle B, this would have to be side B. As long as you're consistent, that's going to work. All right. So moral of the story. Let's figure out what is angle B is probably the easiest thing to find out. So what is the measure of angle B?
180 minus 90 minus
27.
Yeah. So this is a 90-degree angle, so it's going to be 90 minus 62.7, right? So 27.3 degrees. Now let's go ahead and find B. What trig function am I going to use to find B? Tan. And I could do tan of A or tan of B. It doesn't matter. They're both exact answers, right? So the algebra is a little bit nicer if I do tan of B, but we've got tan of A written right here. So let's just do that one right here. It doesn't really matter too much. So tan of 62.7 is equal to opposite over adjacent. So we multiply both sides by B. And then we divide by the tangent of that angle. So first thing we do, if we're using our calculator, is we make sure that we are in degrees. So mode degrees looks good. So we're doing, what were we doing again? We were doing 8.4 divided by tan of 62.7. So 4.34, I think it's into the hundredths. Were you banned or?
Yeah, we're banned. Mr. Peter said you would see it.
Yeah, I got it. All right, now you might be tempted to use the Pythagorean theorem to find C, and if you go out far enough and do it exact on your calculator, you can do that. But in general, like I would not want to use 4.34 to calculate for what C is. I want to use things that are given to me, so I'm not rounding or using rounded answers to do this. So I could just use my calculator to do that 4.3355, whatever the whole spiel was, and do Pythagorean theorem. Or I could just go ahead and say, well, sine of 62.7 is equal to opposite over hypotenuse. So I can do the exact same algebra, and I get 8.4 over sine of 62.7. And when I do that, I get 9.45. So now I solved because I've got all of my sides and all my angles. I figured out what those are. Does everybody understand why I did it using this method? Right, so I'm not rounding anything or anything. I'm getting exact answers. Well, when in doubt, when solving triangles and things like that, go back to the things that are given to you. All right. Number 2. A child is holding the end of a string 2 feet off the ground. The other end is attached to a kite. The string is 75 feet long and has an angle of elevation of 30 degrees. How high above the ground is the kite? Take a moment and draw a picture. So there's our kid holding the kite. Got a long arm there. 2 feet. All right. So 75. Does that go on the hypotenuse or on the bottom side? Hypotenuse. And then I've got 30 degrees here. And so if I'm trying to figure out, let's just call this y. Sine of 30 degrees equals opposite over hypotenuse. So I get 75. What's sine of 30? Don't reach for your calculator. Sine of 30. 1/2, right? 30 degrees right here, the y value is 1/2. So 1/2 of 75 is 37.5. So is the kite 37.5 feet off the ground?
39.
39.5, right? Because it plus that 2 feet. So 39.5. All right, are we all good on that? All right, so this one is kind of interesting. This, surveying back in the day, and to a certain extent, it still can happen these days. But these are the techniques that we have to do to measure the heights of tall buildings or tall items in nature, whatever that might be. Because we couldn't very well climb to the top of a mountain and stick a measuring tape straight down, right? And so here we're saying you're standing on a level ground 800 feet from the base of Mount Rushmore. Looking at Abraham Lincoln's face, you note that the angle of elevation to the bottom of his face is 32 degrees, to the top of his face is 35 degrees. Find the height of Lincoln's face to the nearest tenth of a foot. All right, so we've got I know he's not wearing a top hat in his Mount Rushmore thing, but so there's his face right there, and we've got this angle here is 32 degrees, and this one here is 35 degrees. So, do you agree with me that if I find the whole height and then I subtract the height from the bottom of his face, if I take the blue minus the green, that's going to give me the height of his face? All right, so let's just call that, I'll call that y. So let's figure out what h is. Well, in both of these cases, this x distance is 800. So tan of 35, right, we're going to use tangent, is equal to h over 800. So I get 800 tan of 35, and I'm not going to plug that in yet. Everyone agree on that? What's y going to equal?
Tan of 32. Tan of 1 equals h over 800. Or y.
Okay. So tan of 32 is y over 800, and so I get y equals 800 times tan of 32. So I'm going to take this number minus this number, right? Number in the blue minus the number in the green. And when I do that, that's going to give me the height of Abe's face. So I can just do it. There was a 800 in both of them, so I just factor that out and make it a little bit quicker to plug it in. Tan of 35. Oh, I didn't get the 5 there. Tan of 35 minus tan of 32. I get about 60.3 feet. So about 60.3 feet. Any questions on that? Bearings. So bearings play a role in this chapter, in this section a little bit, but they also play a big role when we talk about vectors. And so bearings are a way of identifying certain, like if we're orienteering or something like that, a lot of times we'll use bearings. Now, the acute angle measured from the north-south axis is going to be our bearing. So, looking at at 8. That angle is 20, so I'm looking from the north in this case, because that's basically the opposite of our reference angle, right? 20 is our reference angle. The complement of that would be our bearing. So what number do I get from that? 70. So how do I write that? I'm going to write that as north 70 degrees east. You can think of it, I'm starting at due north and I'm bending 70 degrees to the east. That's kind of how I think of it. So what would B be for a bearing, do you think?
West, 50 degrees north.
We're always going to bend from north or from south. So it's going to be north 40 degrees west. Right, I'm starting at north and I'm going 40 degrees to the west. Whoops. C. Well, now this one, I'm going to start from the south, right? It's always an acute angle, so it's always got to be less than 90 degrees. So what's the letter C going to be?
South 18 degrees.
South 18 degrees east. And finally D.
South 38 degrees.
South 38 degrees west. So it's always going to start north or south and then we're bending to the east or to the west. You leave the entrance to a system of hiking trails and hike 2.3 miles bearing south 31 degrees west. So there's 31. We want 2.3 miles. Now I turn 90 degrees clockwise. So I was heading down. I'm going to turn clockwise. So now I'm heading northwest. So I've got this right here, and that's a right angle. I'm going to go up to, let's try and make it somewhat to scale. Looks something like this maybe. 3.5 miles. So, how can I figure out what this angle theta is? Yeah, would you agree with me that tan of theta is equal to opposite over adjacent? So 3.5 over 2.3. See how I got that? So I'm just treating this as a triangle sitting in space. So theta then is equal to tan inverse. Of 3.5 over 2.3. So I get 56.7 degrees. All right. Sorry, I skipped right to I skipped right to B. I skipped A. So let's just finish B and I'll come back to A. I don't know why I skipped A. Yes.
Where'd you get the tan inverse from?
That's how I solve this equation, right? If you think about it, tan inverse of both sides. Tan inverse of tan, again, they don't, we kind of learned in general that they don't always cancel off, but theta is acute, and tan inverse actually, it does. So it ends up canceling off just to be theta. And so I get 56.7 degrees. So what is my bearing? Sorry?
Is it south 87.7 degrees west?
South 87.7 degrees west. Do we see how we got that? This angle, the right theta was 56.7 degrees plus the 31 degrees there gets me to 87.7 degrees. And so the whole measure of this whole angle here is 87.7 degrees, and we're bending west from south. So south 87.7 degrees west. How am I going to do part A? Yeah, Pythagorean theorem, right? That one. A squared plus B squared equals C squared. And so I end up with .2 miles. Any questions on that?